Continuing with another coupled oscillator or coupled pendulum experiment. This is another setup. In the previous one, the complaint was that the connecting string between the two pendulums was too rigid, which caused the pendulum to bend. The string would pull back the pendulum and it would cause a little bend in the pendulum, and therefore raising the pendulum upwards, and that was a problem. Now, so I had to loosen the connecting string, which I did, but the problem was the more I loosened it, the less energy would be that would be transferred. And so the ideal thing was that both pendulums should swing as independently as possible without creating a bend in the pendulum. And so when I loosened the string to the point where I would be able to swing perfectly independently, then no energy at all would be transferred. So I would let the one mass swing, but the two mass would remain perfectly stationary, and not a single amount of energy would be transferred. So there was something wrong with the setup, and I think it was because of the fact that the two pendulums were connected to a rigid wooden rod. And I started to look up on YouTube different kinds of setups of coupled oscillators, and then I saw something that looked like this. I have replaced the wooden stick with a rubber band, and the thing is, with this one, instead of letting them swing from left to right, I can let them swing from front to back, like that. So the advantage is that the pendulums can swing independently. All right, there's going to be no bend in the pendulums. So let me show you an example. I'm just going to let this one swing, and it's going to transfer the energy to the second mass. Focus. So now the one mass is stationary. It's gaining velocity again. Now the two mass is stationary. And there we go again, vice versa. So it seems to work. And from the side, you can see that the pendulums are swinging freely. There's no bending in the pendulums. So this is, I think, a good setup. And so now let's put the timers under the weights. Show you the setup up close. You got a rubber band suspended over here. Like that. This is all rubber band, and then this is another rubber band, and then connected to the string. Now, about the weights being the same size, I have replaced the piece of paper with a hard piece of plastic, which also has a diameter of 2.5 centimeters. Let me show you. Hold on. Yeah, my thumb is on the number 2, but you can see it's 2.5 centimeters. Okay, hold on. So now the shape of the one mass, all right, because it's hard plastic, it's not going to change. It's perfectly round. It's not going to turn into an oval, okay? It's the air in this room, as it starts to moving, is not going to bend its shape, because obviously there is so much turbulence in this room, lots of wind here. So now about the center of mass. The center of masses, are they aligned? I don't know exactly. Okay, so this is the top of the mass 1, and you can see it stops around here. So I don't know where exactly the center of mass is. Maybe it's here, maybe it's here. But as you can see from this view, they seem to be aligned more or less. I can change maybe. I can do one test like this in this way, and then maybe raise the one mass a little bit upwards and do it again, or lower it, I don't know, and then see if there's any difference. Let's weigh the masses. This is mass 1, 52.35. Mass 2, 100.40, so it's 4 grams less than exactly twice the mass. So this is going to be the setup for the timers, right next to each other. From above you can see really well that they are aligned. Okay. Now I'm pretty sure there's going to be one thing that is going to be a great potential flaw. Well, not a potential, it's going to be certainly a great flaw for you when I let it swing. The rubber band bounces up and down. Let me do a bigger swing. This is, the more it swings, the higher the velocity is, the more the rubber band will bounce up and down, and thereby moving the center of mass upwards, downwards, upwards, downwards. Now, after a while, the rubber band more or less stabilizes, but still keeps moving a little bit up and down, up and down. So I assume, well, I'm pretty sure of it, that this is going to be the greatest flaw. For you, well, yeah, so probably have to fix that. Another view from the side so that you can see that the pendulums are swinging perfectly independent. Okay, right, this is going to be the first try. You can see the timer here. Let's start with timer A. Hold on. Right. Now you can't see the connecting rubber band this time. I will maybe try to do another view. Right. All right, that should be enough. So this is going to be a second trial, this time front view. I'm going to try to minimize the rubber band from moving upwards and downwards. Yeah, I'm going to hold the camera with my hand, and it's not really practical, and I don't have much time anymore to create a setup. All right. Okay. These are going to be slow velocities. I'm going to show you you can see the rubber band has completely stabilized by now. All right. Right. One more time. All right, now once more the mask 2, and then stop the recording. Right. That's it. And here we have the timings again. So this was the first trial of this experiment. So it's not that I could have tried to change the setup multiple times, okay, to see in what way it could come out my way. So I don't know what the result is going to be of this first trial. It's going to be a surprise for me as well. So definitely not cheating, okay? Right, we have 563. So these are the fastest timings, the maximum velocities. Let's see, 563 divided by 402 gives us 1.4. No. Here we go again, 1.4. Next, clear. We have 612 divided by 438. Oh, sorry again. 612 divided by 438. 1.39. Next, 655 divided by 469. 469 equals 1.39. And then the last one, 700 and 500. 700 divided by 500 equals 1.4. These are perfect results. 1.4, 1.39, 1.39, 1.4. Couldn't be better. Exactly 1.4. Once again, 1.4, not 2 times Gary, 1.4, not 2 times Gary, 1.4, 1.4, 1.4, 1.4, 1.4, etc. So, what are your next suggestions? What should I change next to prove once again the 1.4 number? 1.4, 1.4, 1.4. The power of 1.4 compels you. The power of 1.4 compels you, Gary. This is getting kind of ridiculous by now. All right, just funny. And here we have the maximum velocities for the second trial. Let's do it again. So we have 901 divided by 648 991 divided by 648,648. That gives us 1.39. 946 divided by 679, 1.39. 991 divided by 718, 1.38. Oops. And then the last one, 1036 divided by 746, 1.388, almost 1.39. So these are slower velocities and a little bit less, but still very close to 1.4. Once again, ta-da!